Hi, I'm Lee, and this is NASA Now. Engineering at an incredibly small scale. We'll zoom in on the futuristic world of nanotechnology. And just how small is a nanostructure? Try this on for size. 10 nanometers is 1,000 times smaller than the diameter of a human hair. Now that's microscopic. That's ahead. First, here's what's happening at NASA Now. NASA has released the first images of Mercury captured by the Messenger spacecraft. This is the first time a spacecraft has recorded images of Mercury in orbit around the planet. Messenger's goal is to snap 75,000 images over the next year. This amazing spacecraft successfully achieved orbit around Mercury on March 17th. Messenger's path included 1 Earth flyby, 2 flybys of Venus, and 3 flybys of Mercury before it went into orbit. At its closest point, Messenger will only be 200 kilometers or 124 miles above Mercury's surface. Now, let's take a look at the past.
The world's first nanoscale book was published back in April of 2007. Using nanotechnology, scientists from Simon Fraser University in Canada carved letters into 30 microtablets using a gallium ion beam. The book, entitled Teeny Ted from Turnip Town, has a resolution of 40 nanometers. Only catch, you need a scanning electron microscope to read it.
Manipulating matter on a molecular scale. It's called nanotechnology. And here to tell us how NASA is creating and using nano devices for space exploration is research scientist Dr. Michael Oy from NASA Ames Center for Nanotechnology.
My name is Dr. Michael Oy, and I work on nanotechnology over here at the Center for Nanotechnology at the NASA Ames Research Center. Nanotechnology is where you're trying to make something that's useful out of these very small feature sizes, and these feature sizes are about 100 nanometers or smaller. And just to put this in perspective, 10 nanometers is 1,000 times smaller than the width of a human hair. Nanostructures and nanodevices are feature sizes that have lengths that are less than 100 nanometers, and some of the biggest areas that you may be aware of are in computers. The reason why that we've been able to make those much faster is because they've been shrinking in size. Same thing with the memory. The reason why the hard drives are able to increase its storage capacity is because the feature sizes are getting much smaller. I'm currently working on these nanowires, and you can imagine that this nanowire is so small that you can't see it with your eyes. You have to look at it in a microscope. Now the thing is, when you get down to those small feature sizes, there's a lot of great things that happen to the mechanical properties, but also the electrical properties that you can take advantage of to try and make these power generators. You can imagine that these nanowires, they're something like this, but again, really so small that you can't see with your eyes. But you can imagine that this can be potentially woven into clothing, because as long as you bend this, then you can generate power. You can also put them into flags, for example. So you might be able to put it into some sort of a material that can flap in the wind. And by doing so, you can generate power just from that mechanical motion. So a lot of those different applications can be used from these nanowires. You can imagine that there's a lot of space exploration that's dependent on solar panels. So if you start moving farther away from the sun, then you would have to do something other than use solar panels. So one of the things that might be useful to try and generate some power is to use these piezoelectric nanowires for just mechanical energy harvesting that would otherwise have led to wasted energy. So if you could somehow recollect that energy, then you can effectively make more energy efficient spacecraft potentially, and that could be useful for long scale exploration applications. I think nanotechnology is an enabling technology, just like the way railroads and cars were about 100 years ago, just the way the textile and the industrial revolution was about 150, 200 years ago. I think the nanotechnology in itself is going to open up a lot of new doors and avenues in the next 50 years. That's going to allow a lot of new different devices and functional products to come on the marketplace. So it's very exciting to be a part of that.
Did you know the prefix nano literally means 1 billionth? That means that a nanometer is 1 billionth of a meter. Now you know.
Hey teachers, here's something you and your students can really focus on. Check out the module feature, Virtual Lab.
In this NASA Explorer School's content module, students can operate a virtual scanning electron microscope to examine 90 different samples of real specimens.
Well, that's it for NASA Now. Be sure to tune in next week when we examine the subject of human research on the International Space Station. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.